All right, welcome to chapter 3. So we are going to, again, split this up into a few different topics. So we're going to be working with some fundamental data types, and then we're going to look at a couple of other classes that we can use. So I already touched base in chapter 2 on fundamental data types. We're going to go a little bit more into detail on them here. So some of this might be a repeat, but that's not a bad thing. All right, so if you see the words string literal, now this is not a fundamental data type, but a string is a class and a literal would be anything that's in double quotation marks. So if you see that, just know that's what it's talking about. All right, we're going to talk about just a review on how to name variables and when we use variables. So again, it's letters, digits, and underscores. Cannot start with a digit. It's case sensitive, so if you use uppercase or if you use lowercase and then combination of upper and lowercase, it has to be exactly the same. You can't use reserved words like public or int. There's no symbols except the underscore. That's the only one that you can use. And when you're making a class, you need to capitalize it. That's not a must, it's a convention. And a convention is just something that all programmers have agreed to do. All right, so here this one would not be because it starts with a number, but this one would not be because it has a space in there. So you would have to have an underscore or do a camel case where it's all one word. And then make the second word uppercase. But again, that's not going to work. And the next three work. This would probably need to be a class. This would probably need to be a class as well. All right. So remember, it's case sensitive again. So Sam does not equal Sam all the time. All right. And so it's just used to name something. That's all it is. Try to make it specific. A is not the greatest thing to name it, although sometimes we're going to do that. If it's just a really quick variable, we're going to use temporarily. Yeah, don't use those symbols. So, all right. So again, it is basically a variable is a storage location. And so we take this piece of memory and we put something in it. So if it's what we call a primitive data type, like int, double, boolean, or char, then that's just going to be the name of that little storage location. If it's a class, like an object reference that's pointing to a class, then it's going to hold the memory location of the actual object. So here, string is a class, and so greeting is pointing to the memory location of where hello world is stored. Here, with would be an integer, so this is the name of the memory location. It's just with, and then 20 is stored in here. But again, if this was greeting, then I would have a memory location. The location of the memory where the whole object is stored, or where it starts. Okay, so it's basically a named container. Yeah, so this says the same thing. When you are assigning into a character, you need to put them in single quotes. And these are our basic primitive data types that we're going to use in Java. Again, variables can hold objects. Again, it's an object reference that it's pointing to. And a variable can also be the name of the class. But all right, so when you give a variable a data type, like when you say int age equals 10, that tells a computer how much memory location to set aside to store some information in there. So an int would be maybe this size, a double, which has a decimal and could potentially have a lot of numbers after it. After the decimal would be a larger size. A char is pretty small, and a boolean is even smaller because there's only true or false that could go in there. So the size of the memory location is what it's telling you. So there's really 6 types of data for numbers, but we are only going to use these 2, ints and doubles. So an integer, again, has no decimals. A double has a decimal. It could have like 6.0, but it does have a decimal value associated with it. These are types of decimal numbers, but it just changes the memory location size. So we aren't going to use any of those. Float is used in Python. all the time. They don't use double in Python, they use float, but float and double both exist in C++. So, but Java, the AP subset just wants you to use doubles. Double is, you can see here's the memory location, and you can see a double has enough space for more than a float does. And so that's why they want you to use a double. So, and you can just kind of see all the different sizes. This is not an important table, but there is a limit to the how big a number can be if it's an integer. And so it's like 2 to the, I can't remember what power it is, maybe 32nd power, but it's like negative 2 billion to 2 billion. So if you go like to 3 billion, basically what's happening here is you have this number line and you can kind of go out of bounds. So let's say this is 2 billion out here. If we want to get out here, then it actually wraps around and gives you a negative number. So there is a limitation to how big of a number that you can use with integers. So we aren't going to get anything, we aren't going to use anything beyond 2 billion, but you can mess around on your own if you would like. Okay, so we've already talked about declaring a variable. You give it a data type, so that sets aside enough memory location to store something in it, and then you give it a variable name and you put a semicolon in there. I don't know what that is, but you need a semicolon in there. So int count, double X. You can do multiples here, double X with a comma, or you could just do it on a separate line, which is probably better. So double X, double Y, char C, circle. This is, again, holding a memory location for a circle object. So there's your object reference. The same thing for strings. So these are all declarations. Nothing has been stored in these memory locations. It just sets aside enough space in memory to store something in there once we determine what it is. So then we're going to define it by using, by storing some number in there. And we're going to use it with what's called an assignment statement, which is a single equal sign. It is not equality. It's an assignment statement. So there's kind of a big difference. So if you forget to put something in here, let's say you're in main, and you forget to put something in here, you're going to get an error here that says it hasn't been defined. Unless you're in a class, it automatically sets that if it's a private variable to 0. But here we're just going to be in main. If you've only declared a variable, there's no way that you can access what's in there because you haven't stored anything in there. So you do get an error. Tyler, that scared me. All right, so here's your assignment operator. And basically it takes anything that's over here and it stores it back into what's over here. So this is the name of your variable. So on the front end of the assignment statement, it's only one variable name. You can never do anything else on the left side. It's just a variable name equals. Over here, you can have a whole bunch of stuff. You can have a big, long mathematical expression, but we are basically going to calculate this first and then store it back into the variable. All right. So here it's not calculating anything. It's just storing things in there. These are assignments. This is an assignment and a declaration and a definition, I guess you could say, together, because we're saying, hey, put enough memory space aside for an integer and store 5 into that variable called count. So again, declaration only, definition and assignment, which is declaration and definition together, and then assignment only. All right, you can read that on your own. I've beat that to death. All right. Different ways we can use variables. So we've talked about this again, private instance variables. And basically we declare them in the private instance variables, and then in the constructor is where we define them. That's, remember, with constructors, we give them a value. It's the job of a constructor. Local variable, all right, so let's talk about a little bit more about integers. There is something called integer.min value and integer.max value. These will actually, if we type this into our computers, we will see what the min and max value is. And I think it's those largest 2 billion and something. But these are, oh, notice they're all capitalized. These are actually what is called a constant value. It means it never changes. And it has a specific value associated with it. So we don't have to remember exactly it's 2 billion and some other stuff. We just know that there's a min and max value. We're going to use these quite a bit throughout the course of the year. As yeah. But again, no fraction part to integers. And then doubles, no, there's no commas. So if you have a large number like 1,312, there is no comma there when you're typing it. Sometimes a number's so big that it gives it to you in scientific notation. This means times 10 to the 24th. This means 1 times 10 to the negative 14. So for very large and very small numbers, it's going to give it to you in this E notation. So just kind of keep that in mind. So we can actually store an integer value into a double. It's not a problem. What it does is it will just attach the 0.0 to the end of it. All right, so in case you're interested in how to format numbers and get it to print out like a certain number after the decimal, I have some slides in here. You can go through and read those if you would like. It's up to you, but we're not going to do anything like that. Okay, so again, calculations. What we're going to do is we're going to do some calculating on the right side and store it back into the variable on the left side of an assignment statement. So you'll have to, and so we can have numbers over here. We can have variables that we're doing stuff to if we've already defined them somewhere else. But all of the, please excuse my dear Aunt Sally, order of operations apply in Java. It will do everything for you, the precedence. So it does any parentheses first and then exponents. And then multiplication and division, whichever comes first from left to right in the sentence, and then addition, subtraction. So here's our operators that we're going to use when we're going to do some kind of mathematical expression: addition, subtraction, multiplication, division. And then this one is going to be new. This is called the modulus, and we'll talk more specifically about that in a minute. But in case you're interested, if you wanted to just look here, if you had, of course, this says 6 plus 5, and it's in double quotation marks. And when it's in double quotation marks, it doesn't do any calculation here. It just prints exactly what's in the double quotation marks to the screen. So that's why it prints this. And then plus, and you can notice here, I put my expression in parentheses. So it will actually do the calculation here first and then print it out. So it can actually, system.print or print lines can do mathematical computations within them. Okay, so now integer division is a little tricky. Did I have that on here? Yeah, this one, if you notice here, 6 divided by 5 actually gives you 1. It doesn't give you 1 point whatever, it gives you just 1. And so, but all the rest are calculated normally, and that's because what's on each side of the division is an integer. So with integer division, it does what's called truncating it. So if you have an integer on both sides of the division symbol, it will divide and discard the decimal portion of it. Okay, so 2 divided by 3, even though we all know it's 0.6, I guess we don't all know, 0.666666666. So yes, it is getting put into a double, but it doesn't get put into a double until it truncates the two integer divisions. So this actually gives you an answer of 0. And so we have to be very careful with integer division. I think we had a program in chapter 1 we did when we did those reciprocals. I think it was the sum of reciprocals that we did together. And so I don't know if you recall what we had to do, but if I really want this 2 divided by 3 to give me the double value of it, you either are going to do 2.0 and divide it by 3, or 2 divided by 3.0. We have to make one of them into a double in order to get a double out. So again, integer division, if you have an integer divided by integer, the answer is going to be an integer. So that's a little tricky. So here's how we can fix it. We can just change it in one side or the other of the division into an equals. Okay, so now as long as one side or the other is a decimal, not a problem. It'll do the calculation. Your compiler is set to give, I can't remember how many places, significant digits after the decimal, but it's pretty consistent. Again, if you just want to go 2 places, you can go back a few slides and look how to format your numbers. All right, so now let's just talk about the modulus. So the modulus gives you the remainder. Okay, so this modulus, it occurs pretty much in every programming language that there is. So it basically is just going to give you the remainder after you've divided. All right, and it works for integers and it works for doubles. Okay, so if we have 45, and then here we have 45, basically 45 mod 10, it's really saying take 45 divided by 10, and your remainder is what it's going to give you. Okay, pretty simple. If you take 45 divided by 10, you know you get 4, because remember, an int divided by an int, we'll just say this is an int, divided by an int will give you the truncated part before the decimal. But modulus is basically just the remainder. Okay, so if it's nice and even, 9 divided by 3 is 3 with no remainder, it's 0. If what's in front is smaller than what's after the modulus sign, it's always this number. So think about that. 3 divided by 9 is 0 with the remainder 3. So it's always the number. So if this is smaller than what's after the modulus, that's your answer. If it's larger, you just say, hey, how many times does 3 go into 11? Twice, right? And then if you have a negative somewhere, then it's just a negative answer. We can use this with doubles as well. You can't in C++. It doesn't work. You only can use modulus with integers in C++. But with Java, they switched it up a little bit so that you can use modulus with double values. So if we take this 42.25 mod 10, we want the remainder. Basically, you can just say, hey, let's see, 10 goes into 42 4 times, right? And then if you just subtract, that's going to be your remainder. You can do long division if you want. But sometimes it's just easier to think about it. How many times does 10 go in there? 4 times what would be left over? That would be your modulus value. So the modulus is just the remainder. Okay, same thing here. 2 goes into 8 4 times, and so that will give you 8. If you take away 8 from here, you get 0.27. So, and there's another example. This is a little bit harder because you got to figure out how many times 2.1 goes into 6.7. Hopefully you can figure out it's 3, and then you just subtract them. So there's some examples. Okay, so when you're using like some type of an operator, division, modulus, and you're mixing types, what happens is, so if you have an integer and a double, it's always going to be a double answer. Okay, so let's see, what am I trying to say here? So if you have an int and you add another int to it, you're going to get an int out. And same thing if you change this to multiplication, subtraction, division, or modulus. But if one side or the other is a double, then your answer will be a double. Okay, so just kind of keep that in mind. Also, if you try to have an assignment statement, and let's say this side is an int, we try to put it into a double, that's fine. It'll just attach the 0.0 there. But if we're going the other way, if we're trying to say something on the right side is a double, and I want to store it into an int, you're going to have an issue there, because think about the memory location of an int. It's much smaller than what is a double, and so it won't be able to fit into that little small location. So this is going to give you an error if you ever try to put a double into an int value. All right, so you can kind of go through those on your own. So that's what we were just talking about. Yeah, same thing. Okay, so now maybe sometimes I want to take like the truncated double value and store it into some integer value over here. Maybe I want to do that. So even though you can't do that normally, you can do something called casting. And what casting does is it temporarily converts it into that data type. So here I would just have to put the word int in parentheses in front of the 5.2. That would truncate temporarily the 0.2, and then it would put the 5 into the integer value. So that's called casting, and we actually will use that occasionally. So here, this is going to convert the 1 divided by 2. So remember what we did before? We had like 11 divided by 5. Oops, and I wanted to put a 0.0 in there to so that I can make sure it goes back into a double. Well, here we have variable names in front of it, so you can't like put a 0.0 after the variable name 1. And so what you have to do is temporarily cast it to a double. And so then that will put that 0.0 on there, divide it by 2, so you don't get the truncation going on of 2 integers being divided, and then it would store it back into decimal. As long as one side or the other is cast to a double, then it will convert it into a double. But it's only going to temporarily change like this 11 to a double value. And then once it's done doing that calculation, then it will be right back at 11. You could put double in front of each of them. So there'll be times through the year that we're going to do programming assignments that you may have to cast. So just know what casting is, just putting the data type in front of a variable name or a number to cast it. All right, so you can go through these. All the answers are on the next page, so I'll go through those at your leisure. And then again, remember casting truncates it. If you want to convert it to a double, that puts a 0.0 after it. So these are more examples you can go through on your own time. I don't want to take up too much of your time. This is a little bit longer of a lesson. All right, so these are shortcuts. So these are called compound assignment statements. So basically, if we want to take two things and add them together and then store it back into the first one, you can shortcut it by saying plus equals. So really, this really just means A equals A plus B. This minus equals really means A equals A minus B. And the same for all the rest down. Here's another shortcut. If you want to just add 1 to a variable and store it back in that variable, A plus plus will work. And if you want to subtract 1 from a variable and store it back into that variable, A minus minus works. All right. Those are called unary operators. Let's see, these are the unary operators. It means it operates on one, it's operated on one item. So I'm making it negative, right? I'm plussing it. I'm adding 1 to it. I'm subtracting 1 to it. This we'll get into in the next chapter. It means making it not. So these, this actually is what your computer calculates first. Anything that has a making a number negative or adding 1 to it. So talking about that, I want to add this into what's called a precedence table. So of course we know that please excuse my dear Aunt Sally is kind of the order of operations. So parentheses are first. We don't have anything to do with exponents yet. We'll do that later. But then the unary operators come in. So it is adding something there to your normal order of operations, and that's just the plus plus or the minus minus, or making something negative. And then we have our multiplication and division from left to right. Modulus included in there because modulus is division and then find the remainder. And then it will evaluate plus or addition and subtraction. And this last one, this is an assignment. That should make sense because it will do the whole right side. That might have a combination of operators in it. Maybe it has something like this with some numbers on either side of them or variables. And then after it's done calculating, then it assigns it back in. And these are also assignments because you're just adding and then storing it back in. But okay, so here are some of the ones if you'd like to look at the answers, just so you know, this is 3.14159. It's all stored in there for you. And we'll look at that when we get to our one of the next videos in this chapter. So, all right, so here are the answers. You can kind of go through those, try them out and see if you get the right answer. Okay, so enough about numerical types, integer, double. Now let's move on to chars. So chars are a single letter and it would be stored in single quotes, single quotation marks. It's based on a Unicode chart, which we will look at in a little bit. Chars are stored in memory as actually integer values. I will show you that chart here right now. let's start with, what did I just do? Oh my goodness. All right, so you can see here that the ASCII value for A, I drew right through it, it's 65. And it starts with capital letters and it goes down. So 65, 66 is capital B all the way down. So they each have an integer value associated with them. And then it does some things in between before it gets to lowercase. And lowercase a has an ASCII value of 97. So they do this because we want to be able to alphabetize things. And so this way we can tell what comes alphabetically before by using like a less than symbol at some point in time. So just so you know, this is our ASCII chart. You don't have to know all of these numbers. You will have a chart in front of you, or there's ways for us to figure it out on our computer. But just know that behind the scenes, every single letter has an integer value associated with it, as well as do characters and numbers and symbols. So pretty much anything on your keyboard. All right, so let's go back here. So yeah, there's, oh, I guess I did. I kind of just clicked on that. Watch this. Oh my gosh. Well, it doesn't want to open it. Well, it's a good thing I went and looked at it. Okay, so again, you should never have to look any of these numbers up, ever. So please don't do that when you get to like the test or a programming assignment or something. You don't have to look them up. On the worksheet, I'll give you the chart that you can refer to it with. So now, here's the thing. If we're putting a character into a character over here, it's going to print out a character. Here, I'm going to take this, and I'm going to take this 65. It's going to make it the character that has a 65 integer value, which is, again, a capital A. All right? Now, what this is going to do, this is going to take the B value, which takes its integer value of 66, add 1 to it, which is 67, but store that 67 back into the character value. So what happens is it matters what's on the left side if we're storing it into a variable. If I just put, hey, take B and add 1 to it in a system.out.println, I'm not storing it into a character value. Here's when you're going to take the ASCII value and add 1 to it, and then it just simply prints that ASCII value. So this is going to print 67 for you. So it kind of depends. Am I storing it into something over here? If I had something like this, int x equals b plus 1, it is going to store the 67 into x. So again, this side is an integer value. So when you're in the print line statement, it's always pretty much dealing with an integer value. I could force it into being a char by typecasting it. I can also typecast this. All right, in a system.out.println, this would now print out the capital letter C. So it first makes it into 67, and then it typecasts it into a capital letter C. Here, I could typecast this into an int. I could put int in front of alpha, and it would typecast that into 65. So you can typecast with ints and chars, and you can typecast with ints and doubles, but they're two kind of separate groups, and that's all you can really typecast to. You can't use it with strings or anything like that. So, all right, Booleans are simply true or false. That's what prints out to the screen, true or false. And so now we're gonna stop, and you have a couple of worksheets to do. One is called variables, and one is called precedence. And we'll continue with more lessons later on this chapter.